So I'm Shashank Bishnoi. I'm a professor at the Indian Institute of Technology, Delhi. Over here, we've been working on limestone calcined clay cement at IIT Delhi for the last 12 years. And during these 12 years, we've gone through a journey that we're going to try to tell you in stories. We're going to try to tell you about that journey and what we learned from that journey over these years. So first, to try to explain what Lc3 is, how it is different from all of these different cements. When you get the chance, do pass by. The lunch will be there. This is not for eating. You see these boxes over here. You have this box over here that explains what ordinary Portland cement is usually made of. A lot of clinker and some gypsum mixed along with that. The idea of Lc3 is that you can reduce the amount of clinker in the cement. Currently, according to the standards that we have, you can have 50% clinker, and the rest of it would be calcined clay, limestone, and gypsum. What we are working on right now, and you'll see a lot of results from that, would be cements that can have as low as 25-30% clinker and still give you the kind of performance that you would expect. You can also see here some of the ingredients kept over there. This calcined clay, you see a reddish, beautiful reddish color over there. If you don't like the red color, that's fine. We have some gray variants for you as well in this bowl. We're going to talk about all of these things during the course of this workshop. Now, obviously, depending on your situation, you would not be comparing Lc3 with ordinary Portland cement. You may have another type of cement that you would like to compare it with technically, commercially, environmentally. The comparison may not be with OPC itself. The comparison may be with other cements. For example, in the case of India, it would be with fly ash-based PPC, Portland pozzolanic cement. This fly ash-based PPC already contains a lower amount of clinker than OPC. We're going to look at a lot of these comparisons during the course of this workshop as well. But the idea of Lc3 is that you can bring down the clinker content at least to 50% and even lower, and still manage to get a dense microstructure because the clay, the limestone, and the clinker, they're all reacting with each other. The biggest advantage comes from the limestone reacting in this particular case, as I'm going to explain to you in the next slide. What is happening is that in the clinker, you have various phases that are present. You know, there is A light, there is B light, they react with water, they produce calcium silicate hydrate, and they produce calcium hydroxide. This calcium hydroxide can now react not just with the clay, that is the aluminosilicate mentioned over here, but also the calcium carbonate, which is in the limestone. So limestone, which is otherwise usually an unreactive material in cement, starts to react, starts to produce carboaluminate phases that fill in the microstructure that give you a better strength, a better durability despite the lower clinker content in the cement. This is something we're going to see over time. Another advantage of limestone is that we know that clay is a material that takes a lot of water, but then when you have something like limestone, which can have more rounded particles, which will not have the sheets-like particles or layered particles like clay does, it helps in the workability as well. During the course of the next 2 days, we'll also see the effect of different types of clays. There are many different types of clay minerals. In fact, many a times when we work with other researchers, we even argue what the meaning of a clay is. You're going to see what clay means. Here we're going to talk about different clay minerals. For example, there is kaolinite, there is illite, there is montmorillonite. Most of our initial work has been based on kaolinite, which is called a one-to-one clay, where you have one layer like that and another one, and then the same layer repeating after that. Whereas in the 2-to-1 clays, you've got the middle layer over there sandwiched between the tetrahedral layers in the middle. So these are different types of clays. I don't know anything about those things. And that's the great part about this workshop, that you are not going to hear me speaking, well, almost, you're not going to hear me speaking at all. The people who know about these things are going to be talking about this. We're going to have a geologist talk about the clay. We're going to have somebody who knows about cement chemistry talk about the cement chemistry itself, instead of me, a civil engineer, pretending to know anything about cement. That's the point over here. There are different types of clays. We're going to see how these different types of clays work. But one important thing to remember is we are not talking about agricultural soils. The first thing that people worry about when they hear clay is that we are going to consume agricultural soils. For example, we consume for bricks And then we will have trouble with agriculture, there will be issues with food security. These are not the kinds of soils we're talking about. We're talking about proper mining operations. The idea of Lc3 was that despite having only 50% clinker or even lower, we saw in the initial results 12 years ago that the strength at 28 days was similar to OPCs with clinker of 90%. And that was very encouraging. That forced us to go forward and study the cement further. Even though the early stage may be a little bit different, we found that at 28 days you were getting the same strength. At 7 days we were able to get sometimes higher strengths than OPC, and that was very encouraging for us. These are very old results. We wanted to understand why this is happening, and then we wanted to understand what about the other properties of the cement and the concrete. Those are the things that you're going to hear about in this workshop. There are many advantages. When we looked on paper and looked at Lc3, we understood that we are going to have a reduction of the CO2 emission. Just with, if you don't take the back of an envelope and you try to do some calculations on how much CO2 you would be saving, you will find that you can save 30 to 40% of CO2 emissions during the production of the cement, and still you will have half the envelope left. Those calculations are very short most of the times, but you can have detailed calculations as well. Somebody will show you tomorrow on how these detailed calculations can be carried out and what kind of results you're getting on them. The advantages we saw was that you could use lower grade materials which were not expensive, which were actually available as waste materials in cement plants, in many cement plants, and clays that were also available as waste materials in other kinds of plants. You're going to hear about that later in this program, and these raw materials are easily available. The most important thing was we do not have to compromise on the performance of the cement. But the first and the most important thing for us was sustainability, that we are able to reduce the CO2 emissions by a large amount. The first question one would ask is, does India need to be more sustainable? Have you heard about the country overshoot days? These country overshoot days, they represent the day of the year during which a country consumes all the resources that are produced on its land during the duration of an entire year. India is not on that list. There are many countries. Qatar consumes everything that is produced in 1 year by February 11. Switzerland consumes everything that is produced during 1 year during the first 5 months. India is not on there. That means we consume less than what is produced per year, what nature can produce in 1 year in India. Does that mean India is sustainable? Not really. The reason why we are not able to consume everything that is produced during 1 year is because we have so much of inequality. If you look at India, you see that top 1% of the people share 33% of the income, whereas the bottom 50% share only 5.9% of the income. There are a lot of people in the country who are not able to afford a lot of things, cement included, which is why the per capita cement consumption of India is quite low. If you look at the global average, which is over there, somewhere around 550 kilograms per person per year, India is only around 200 to 250 kilograms per person per year. But with development, that number is increasing. That number, you can see how quickly that number is increasing over time. Okay, there's some effect of COVID over there, but after that, you started increasing once again. That increase means that the cement industry is going to continue increasing its capacity. The cement production in India is going to continue increasing at a very rapid rate. Now, right now, we have a capacity of around 600 million tons in India for cement production. We are producing somewhere around 400 million tons in India. This kind of a capacity increase means that every year we are adding 30 to 40, let us say, 30 to 40 million tons of capacity of cement production in India per year, which is equivalent to all the cement that is produced in Germany within 1 year. That's a huge amount of capacity that we're adding. Now, we have the option of either adding this capacity the same old way, where we are emitting 800, 900 kilograms of CO2 per ton of cement, or we add that capacity with a lower CO2 emission. Also, it depends on whether the old capacity that we have, we continue to operate at those high levels, or we reduce the levels of CO2 emission. Of course, I'm talking about OPC. PPC is much lower. You'll see some of those numbers afterwards. Now, when we look at that picture, when we think about improving the sustainability of cement production in India, there's one more very important fact that we must consider. It is that somewhere around 65% of the cement consumed in India is in the IHB sector, that is the individual home builder sector. People buy the cement in bags and they produce the concrete their own way. It is not necessarily an organized construction where there's a big construction company and a lot of engineers that are working. That means people are buying cement. And what do we do when people buy a product? What do the companies do when they have to sell products to the people? They advertise. They advertise, which is why you land at an airport, you see Amitabh Bachchan welcoming you with the board of One Cement brand, and then you have Rohit Sharma, the captain of the cricket team, welcoming you with another cement brand. Apparently, the water provided in my home city is sponsored by Ultratech Cement. Apparently, all of you know there are two religions in India, right? One is the religion, the regular religion. The other one is cricket. And if you look at cricket jerseys, you can see so many cement brands on cricket jerseys in India. Because, that's a religion, but then real religion isn't very far away either. You see the board of a temple. Even Hanumanji seems to be promoting a particular cement brand on this board. So, that's what it is. The cement, you can understand from this slide, not that we do so much advertising, but that it's people who are buying a lot of the cement. When people buy the cement, these are people who are trying to come out of those lower income levels. They are slowly growing. This market will become very price sensitive. You cannot increase the price of cement production too much. But if you believe the roadmap of Global Cement and Concrete Association, you would have to say that 36% of the CO2 emission reduction that we are promising around the world is going to come from carbon capture, utilization and storage. This is not a low-cost technology. I know in the end we'll have to use CCUS to get to zero CO2 emission, and we have all promised zero CO2 emissions, including India. We are all promising that because we would like there to be a future. If there's no future, there'll be no business. So we would like to have that. So if you go for 36% carbon capture, utilization and storage, this would mean that the price of clinker production is going to increase 3 to 4 times. Would the consumers in India who are looking at these advertisements and buying the cements be willing to pay that much of a higher price? That is an important thing. So the more we are able to reduce the clinker content in the cement, the lower will be the cost of the cement, the lower we will have to spend on CCUS. Because the lower will be the requirement for CCUS. That's where Lc3 comes in. Then it also has to be usable by the people in the country. And which means that very highly trained engineers, like the ones that you see over here, you have seen these people, right? These are the people who are building India right now. We have some friends from L&T. Very happy to have you here. Very happy to have you here. But unfortunately, L&T is not the biggest construction company in India. It is the biggest organized construction company in India. But these guys are the biggest construction company in India. Am I right? Yes. These are the cement has to be usable by these people. So the good thing about Lc3 is once you make the cement, you give it to the regular people who make concrete with the minimum possible technology. They'll be able to make beautiful concrete for you if you tell them how to make it. You take away that technology from them, they'll still be able to make very good concrete for you just with their hands. And that is the beauty of concrete. You can make this whichever way you want, irrespective of what technology you want. You can have the best possible batching plant, or you can have the best possible shovel to mix your concrete. Either works, and this is the beauty of Lc3 that you can do it either way, and you can reduce the CO2, you can reduce the clinker content down to 30% and still get very strong concrete. That is the great point about that. Now, of course, when you reduce the clinker content, you lower the CO2 emissions. We're going to look at some of these numbers more. But the good part is that while you're lowering the CO2 emissions, the cost of cement production is reducing as well. I do not know if the reduced cost of CO2 production will be passed on to the users or not, but at least the cost is not higher. It is not going to increase the cost of the cement in the market, and you can achieve a lower CO2 emission. Which is why, because of a lot of these advantages, there is now a cement code in India that allows the production of limestone calcined clay cement. This is known as IS 18189, code in calcined clay limestone cement. And also there is an amendment coming to the concrete code in India, which is going to allow the use of Lc3. But to get there, we need a lot of work. We need to understand how the raw material is, where the raw material is located, how to identify that, how to make the cement, what will be the properties of the concrete, and so on. For that, you need a lot of work in the lab. You need a lot of work in the field, and it is the people who are going to talk to you today and tomorrow who did all of this work in the lab and the field. They learned from that. They're going to talk about their own experiences in this. You know, when we started working on Lc3 right at the start, the first thing that people said that, but there's no clay. How will you make a cement like this? So we went around, we looked, and we found some clay. And people said, yeah, that is fine, but then calcination is going to be difficult. So to answer the first step, where is the clay, what type of clay? Dr. Rashmi is going to talk to you in the next presentation. She will tell you how to talk about how to find those clays. Then how do you test those clays? We'll have Dr. Rakhi and Ms. Menas who are going to talk about how these clays can be tested. If you want to test them in a complicated way, that way as well, in a sophisticated manner, how to test them simply as well. There will be more people talking to you after that. We have Professor Sridhar Krishnan from IIT Jodhpur, who has been a part of the Lc3 team from the beginning, from the last 12 years. He's sitting right here. He's going to talk about hydration. He's going to talk about microstructural development. We're going to have other people talking about strength. We're going to talk about tests that are carried out in the laboratory, workability, durability. We'll have Professor Ravindra Ketu here from IIT Madras tomorrow, who's going to talk about the life cycle analysis. Our own people are also going to talk a little bit about the advantages of Lc3 over here. So that's a quick introduction to the coming 2 days to you. I hope you're going to enjoy this. I hope I give you a background of what we are doing.